Hi there, I'd like to do a quick update on Schema Stack Assist. Basically, it's a way how to create stacks inside of Schema, right? The little patches, little programs, automatically using LLMs. What I'm trying to aim here at is basically having an end-to-end local pipeline. First, let's do a quick demo, and I will dive into what I'm trying to build here, what I've built so far, and basically where I think it can be improved. So generally it's a system that will create patches for you, patches of animation in Schema. Let's say I want to switch between colors of the rainbow. What's going to happen is that the model is grounded in what is actually available, and it's trying to find the right tools to achieve the purpose. There are many failure scenarios still, many of them stemming from incorrect documentation or indexing on that. So what's happening behind the scenes? We basically have Schema producing a list of blocks, all the different tools that are available. This currently goes out as a log, but can be made better. Then there is a tool that takes the logged out blocks and basically ingests it into a JSON Lines file, so formats everything so it's easy to work with after. Then all of these blocks get indexed, essentially in a simple vector store and a simple local database. And then this is exposed via an MCP to the LLM. So we have basically LLMs that can ask what blocks are available, for what purpose. It can also do some extra things like just validating if something exists when it's coming up with something, get descriptions, and then it basically uses this to fulfill the user request, right? So I want something like here I said rainbow, LLM goes, checks what can be available for a rainbow, color blocks, switching blocks, or like flash in this second case. And then it basically produces some sort of YAML that represents the stack called scenic script, and then it pushes another MCP that just updates a file. So that's the current interaction with that. So basically the LLM then calls this file MCP, updates a file which automatically gets loaded in this test patch. Now, in order to support this, I've also set up a bunch of supporting tools. First of all, the blocks from Schema did not have any descriptions. So we have a tool that's called blockdesc that goes over the definitions of the different blocks and tries to infer, again with an LLM locally, what it could be. And then I have a block review where I can go over these descriptions and validate that things are fine. I see that it often gets confused because the description is wrong. So it thinks the block is doing something, but it's doing something else. So then I can go into the review, actually fix the description to be real and push it back into the system. And then when it's fixed, it usually makes the behavior better. Now, there are issues in this general flow. I'm trying with different models. Some models like Qwen 2507, without thinking, seems to perform quite okay. It doesn't get into loops. The thinking variants get extremely loopy in the level of just constantly looking for blocks or falling into existential dread of conflicting requirements, even though they're not really conflicting. The general setup of the LLM is that there's a system prompt which defines some general context on what a scenic script YAML is, how it looks, what's the structure, the working context of Schema, how things plug into each other, and some general concepts like what are values, what are colors you need to convert. This is like the 6th version, can be more summarized or more specific in some places, but generally it works well. I think what could improve here also are just different example stacks that the LLM could look up and reference. Maybe also the fact that I'm using YAML is questionable. So it seems that the models may be more trained on JSON. It's also easier to validate. I cannot use structured outputs because this structure is generally recursive, and that seems to be a problem. So generally, I'm not sure if the structure is ideal. It's something I developed a few years ago in order to represent the schema stacks in a way that's both human readable, it's very concise, and hopefully also machine readable and easy to generate. So in a lot of cases this works. In some cases I see failure scenarios. With some models, they really have problems to stick to the structure. Maybe they will create multiple root blocks, which is invalid, or come up with different parameters or combinations that are not correct. I had a lot of fun watching Ministral come up with all sorts of solutions. It's a very creative model, sometimes too creative. It came up with new syntax in some scenarios of assigning values to some reference and then referencing those with an arrow, not here, but in other chats. Here you can see it kind of goes like, okay, I'm gonna use this and I'm gonna use this, and then this is the multiply part and this is within an alternate. So it like kind of goes, okay, I have this on the ready, this on the ready, this on the ready, this is the result. I can obviously do parsing that will take the last item, but I prefer to use models that are able to follow the instructions. And also Ministral here was extremely, went like, okay, now I'm gonna make it better, more optimized, and even more optimized and simplified. This was supposed to be final, right? No, but no, let's do a final with a different way. And a final simplified, which is throwing everything away. Then I will write this and make another simplified version. I know, it's just overly verbose, and that's what I seem to be getting with any sort of thinking-oriented models. They tend to overcomplicate, at least with the local ones, right? What I'm testing here are models that fit on my GPU, 8 gigs of RAM, hopefully something that doesn't eat it all up. So the 4 billion coin is a pretty good compromise. And yeah, let's look at the back office quickly. So it's a couple of tools, vibe coded in Go, the file MCP that's pretty simple, read file, write file, something I just needed for the LLM to be able to push the results without me having to actually integrate in Schema directly. That Schema wouldn't be calling the LLM at this point. Makes things a bit easier while developing. So the back office for the blocks, we have a way to parse the logs, right? So these are individual blocks that Schema is outputting every time it's registering a block, in this case range slice. What are the parameters? Potentially what's the documentation of the parameter. In some places I've defined that, in most not, and that's a problem. So using the blocknorm tool, this is parsed into a structured per line JSON. So blocks data like this. So a file like this is much more machine readable, and it's something that I could output directly from Schema. Just didn't want to implement it. Things are faster to implement nowadays in textual code rather than patching everything manually. And so once I have this, I run things through blockdesc, which helps me to basically add descriptions, right? The way that would look like. Let's say I take this model that I have loaded. Blockdesk takes some general context that should evolve and be, a good description of the Schema system. So the descriptions are grounded in some sort of reality. It takes the data, obviously, blocks data. Let's do blocks 2 that are not enriched. We should have an out. So blocks date, blocks description test. And it takes the model name. And this way we're generating descriptions, which are actually also useful for human use eventually. Once we have blocks with descriptions, we can basically ingest them and embed them into the vector store and the database, and then we serve them with the blockmcp. So that's what the LLMs can access and use in the flow. Let's do one last test. Colors with smooth fading. Yeah. Yeah, this is one thing that seems to be always missed. Animate fader parameter. Yeah, this is also one of the failure scenarios. It's forgetting to check each block, and then it's coming up with new parameters. Waveform. And Quen is very stubborn. Done. Better when we have a pastel animation. And finally, let's look at some tests that were funniest today. This was simple transition between white and blue. Also needed some hand holding. What worked kind of well, one point, was making a techno scene. But then I couldn't push the model to make it red. I had to be very, very specific. Yeah, that's it.